What's up, guys? So today we are going to be doing some factoring of higher degree polynomials, such as this cubic function right in front of us here. We're going to be doing this using long division. So the first step that you always want to take in factoring a polynomial with a degree higher than 2 is trying to guess a root. Now I say guess, we're going to be taking a little bit of an educated guess. Possible roots of these polynomials will always be multiples of the constant at the end divided by the leading coefficient. So in our case, that would be 6 over 1, right? There's sort of a sneaky 1 hidden in front of that x cubed. 6 over 1 is, of course, 6. So what are some factors of 6? Well, those could be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now that's quite a few factors, right? That's 8 to choose from. In general, I would recommend starting with trying both plus or minus 1 and plus or minus 2 before any of the higher multiples. For the vast majority of questions or problems that you guys are going to have to tackle, one of those 4 options will generally work out. Now, when I say test these values, what I mean is we are looking for roots. Roots are values of x that make the function or the polynomial equal 0. In our case, if I tried 1, for example, and I plugged that into our polynomial for x here, I'd end up with 1 minus 4 plus 1 plus 6. And if you add that all up, you're going to end up with 4. Now, what does that tell us? Well, 4 is not 0. And that essentially just confirms to us that 1 is not a root of this polynomial, again, because, well, it didn't make the function equal 0. The idea is, if 1 was a root, then x minus 1 would be one of the factors of this polynomial, and that would mean plugging 1 into that factor would get us 0, and that would turn the entire polynomial into 0, so 1 didn't work. So we're going to move on. We're going to try something else. Now we're going to try -1. And I know this seems like a little bit of an outrageous step, just sort of blindly plugging in numbers. Well, semi-blindly, we are sticking with factors of our constant over our leading coefficient. That's sort of why I recommend always try plus or minus 1 and plus or minus 2 first. We don't want you guys just plugging in numbers all day. 99 times out of 100, one of those will give you 0. Okay, so we're going to plug in -1 now. -1 cubed minus 4 times -1 squared. Minus 1 plus 6, that's going to give us -1 minus 4. Be careful with the exponents on some of these negative guys. Remember, even exponents will always turn whatever's in the bracket into a positive. Odd exponents will keep the sign the same, so that's why this is still negative, whereas this would turn into +1, and then the minus 4 keeps it negative. And if you combine all these together, we do end up with 0, so that's awesome. We've gotten our root. All right, now once we have a root, now we can actually start our long division process. So if -1 is a root, well, the corresponding factor to that would be x plus 1. And how do I know that? Well, because the factor that corresponds to a root is the factor such that if I were to plug that root in, the factor would become 0. And of course, -1 plus 1 is 0. As a sort of just easy way to remember that, it's always going to be x plus whatever the sort of opposite signed value of your root is. So in this case, we got -1, so it's going to be x plus 1. If we had gotten +1, it would be x minus 1, and so on. Now, once we've got our factor, we can actually set up our long division process. So what we're going to do is we're going to put the factor that we found outside, and inside the quotient, we're going to put our polynomial. And so here's where the long division process comes in. The first step, we're going to look at our factor. At the first term of the factor, we're going to ask ourselves, what do I need to multiply this by in order to make it become the first term in the polynomial? So what do I multiply x by to make it x cubed? Well, that would be x squared. And when you determine that, what you want to do is put that up on top of your quotient. Now, what I like to do is I line up the x squared terms of my result with the x squared term in the polynomial. So I'm going to put it right above the 4x squared here. Then what you're going to do is you're going to multiply that factor by x squared. So x plus 1 times x squared is x cubed plus x squared. And you're going to write that, you can see, directly below the sort of similar terms in the polynomial we're dividing. And then we are going to subtract those two terms from the two terms above. Now, these two should cancel out. That was sort of the purpose of us multiplying x by the thing that would make it equal this, so that when we subtract them, they'll cancel out. So that's going to go away. But then 4x squared minus x squared, or sorry, negative 4x squared minus x squared is negative 5x squared. So that's what we're going to have here. And then we're going to bring down the next term. You may remember some of this mechanically from when you did long division back in the day with numbers rather than polynomials. The process really is identical, just a little bit more intensive when you have variables with exponents and all that kind of thrown into the mix. But then we're just going to kind of keep going. So now I'm going to be asking myself, what do I multiply x by to get this term? Okay, so originally we were looking for this one, now we're looking for this one. That pattern's going to keep going as we go down. What do I need to multiply x by to get to negative 5x squared? Well, it needs to be multiplied by negative 5, as well as an x to get that exponent to a 2. So I need to multiply it by negative 5x. I'm going to throw that up on the top here. And then I'm actually going to multiply this by negative 5x, which would give me negative 5x squared minus 5x. And then we're just going to repeat. I'm going to subtract. These will cancel out. Be careful with the signs here. X minus negative 5x, double negative there, so that's going to be plus 5x. That's going to leave us with 6x in total. And then we're going to bring down the next value. Okay. And one more round. What do I multiply this by to get this? Well, that's going to be a 6. So I'm going to throw a plus 6 up here. And then I'm actually going to multiply this by 6. That's going to give me 6x plus 6. Which coincidentally, or not so coincidentally, is identical to what we have up here. Now, as the last step, we are going to subtract those, and we will end up with nothing. Now, the thing that we end up with there, that nothing, if you remember, is the remainder. Now, ideally, because we've determined that negative 1 is a root, and therefore x plus 1 is a factor, we actually already know that this is divisible by x plus 1 because we already know that it's a factor of that polynomial. So every time you do this, if you've done it correctly, that is, you should end up with no remainder. So it's a good time to sort of pause. If you get something non-zero, maybe look back at your long division process, maybe double check your root because something has gone wrong there. So it's a good little checkpoint. And so now what we have with that information is that our function can be decomposed into the factor that we know, so x plus 1, times this resulting quadratic up top, so x squared minus 5x plus 6. Okay. Now from here, this should be pretty straightforward. All we're going to do is we're going to recognize, well, this is just a regular old quadratic. I can factor this with sort of our standard factoring technique. So all I'm thinking now is, well, there's no leading coefficient, so no need to do any factoring by grouping or anything like that. I'm just going to ask myself, what adds to negative 5 and multiplies to positive 6? That would be negative 2 and negative 3. So I will factor that out. And there we go. That is our cubic, completely factored, and we are done.